Let us now compute the area of a parallelogram. Let us derive a very general form of the equation and then from there we will go forward. But I also want to link the calculation of area of a parallelogram to that of a trapezium. So let's say in my given shape here A, B, C, D, let me assign some names to each dimension. So the line segment BC is given a name as A units. So is line segment AD because opposite lines are parallel to each other, right? And then there is a distance from A to E, that is a perpendicular distance between two parallel lines, right? And let's say that is labeled as height H1. Okay, now we know that each parallelogram is also a trapezium, right? There is a pair of lines which are parallel to each other, and then there are two lines. We don't care whether they are equal, unequal, or parallel or not parallel to each other, right? So in this case, if this is my trapezium, then I say the formula of this trapezium is equal to area, which is half of the height between two parallel lines, and then sum of these two parallel lines, sum of the distance of each one of those, right? And that will be A plus A. Or in other words, it will be 1/2 times H times 2A, and you can simply cancel this 2 and this becomes equal to A times H. Or you can specify that for a parallelogram, the area can be computed as equal to the base times the height, where base is in this case BC and height is the distance from a vertex opposite to that base. Okay. In that case, if you assume the base is AB, if base is equal to AB, not the BC, right? Then we say that the height is equal to the distance from the base to the opposite vertex, and it could be taken as the vertex C. So the height would be CM. So in that case, you will still compute the formula just like this, the base times height. Only thing is that your reference of base is changing from the base BC to the base AB. That's all, okay? So with reference to this general form of the area developed, let us calculate the area of this given parallelogram with respect to our given dimensions, the CM, which is the height, and the dimension AB, which is the base. Okay, so the base is 4 centimeter and the height is CM from the vertex C to the base AB is equal to 6 centimeter, right? So your area of this parallelogram, as simple as it is, 6 times 4, which is 24 centimeter square. As simple as that, nothing complicated about it. So with that, we are defining that the key points for calculation of the area of a parallelogram is as simple as taking its base multiplying with its height, okay? And the base is, you can pick any side of a given parallelogram, and height will be with reference to a perpendicular distance from a vertex opposite to that base, alright? So that defines your base and your height. And the second key point would be about, if you do not remember the area in general, then break down that complex shape or any shape into its individual components and you go from there. Or the third would be going back to the trapezium model, which is what we used here to prove the formula for this parallelogram. Okay, with that, now let us pause here, and in our next tutorial we will go discuss about calculating the area of a quadrilateral in general. A quadrilateral that doesn't have any specific shape such as a parallelogram or a trapezium. Okay, so let's go discuss about that and learn a little bit more about how to compute the area of quadrilaterals.